Hello, E-Block Honors Analysis Math class. This is Matt Pratt,
And I'm Jamie Rowe.
coming to you from Death Row Studios. And today we're going to teach you marvelous people about a beautiful thing called vectors in a Khan Academy style.
So, the first thing you need to know about vectors is all vectors have a magnitude and direction. Now, magnitude is a measurable size or quantity, and direction, of course, is the direction it is moving in space. So, when we talk about vectors, we will use compass directions. So, north, south, east, and west. Now, when looking at vectors, it always has to have magnitude and direction. So, say we tried to draw the vector of speed. This wouldn't work because it does have a magnitude, but it has no direction. Whereas if we drew the vector of velocity, this would work because velocity has both a measurable quantity and a compass direction. Now, when you measure the magnitude of a vector, say vector AB, so this is the notation you have to use, is obviously like a line segment you would use AB pertaining to the vector you're using, and then with an arrow over the top. Now, if you're going to measure vector AB, you would draw vector AB in a coordinate plane, and say it goes from 3 on the x-axis and up to 2 on the y-axis. This vector would have the components 3, 2. Now, not all vectors will be extending from the origin, so we also have to keep in mind that, say we drew vector CD on another two-dimensional coordinate plane, as shown here, and say this vector went from 2 on the y-axis all the way down to -2, and it went from -5 to -6 on the x-axis. The components for this vector would be -1, -4, because really you're just measuring how far the vector is actually going. So it's not really relevant to where the origin is. You also have to keep in mind that the two diagrams we just showed, that's in the second dimension. Vectors can also be measured in the third dimension, fourth dimension, fifth dimension, as many dimensions as you see feasible. So, but the third dimension would have 3 components. The fourth dimension would have 4 components. The fifth dimension would have 5 components, and so on and so forth. Now, you also have to focus on the direction of a vector. Like I said earlier, the direction is always going to be pertaining to compass directions. So say we had another vector AB, and it came off the origin at a 68-degree angle. Now, 68-degree angle from the origin would mean it's closer to north than it is to east. So we would say the direction of this vector is north of east. Whereas if we had another vector and it came off the origin at a 30-degree angle, the direction of this vector would be east of north. So this same process works all the way around the coordinate plane. So that's basically the basics of vectors, so about magnitude and direction. If you go to our next video, we'll start explaining to you the properties of vectors with the addition, subtracting, and multiplication of vectors. Thank you.